Good afternoon, everyone. I'm Chinmay Shivratriwar, and this is the test sequence for hate speech and objectionable language detection application that I have created. The front end is designed in React, the back end is designed in Flask Python. The model is designed in TensorFlow. I have used long short-term memory for making my model, and the dataset used for this particular model is combination of two datasets that can be found in open source and at any open source website. The first dataset is Twitter sentiment analysis, and the second dataset is hate speech and objectionable language dataset. Now, the main thing that we need to understand before actually moving on to the demonstration of the project is that whatever we have used for data, whatever dataset we have used, they are American dataset, they are not Indian dataset. So there are going to be a lot of statements or lot of hate speeches or statements in that dataset that are not going to make sense in Indian context, but they are hate speech and they will make sense in the American context. Whatever predictions or whatever dataset we are going to get. Oh, so I'm sorry for that. Whatever predictions we are going to get or whatever output we are going to get, some of it is not going to make complete sense because the data set we are using is American, and there are a lot of statements that do not make sense in Indian context but they make sense in American context. So what can we do to improve its output? We can make a data set that perfectly fits in the Indian context. I have tried to find the dataset, but I was not able to find any dataset on internet as of now. If anyone knows any dataset like that, or if anyone can find dataset like that, please put it in the comment section. And because I don't have dataset that perfectly fits the Indian context, some of the outputs of this particular model is not going to make sense. Okay, so without any further ado, let's just start demonstration. So you can see this is our app.js file. As I've said that I have done UI in React. So we are going to start with app.js. This is the client side of our application. I have already the server running and the server is designed in Python. As I've said, it is designed in Flask. The server is pretty simple and it is not a very big server. It is a comparatively small server that does not do much, but that is enough for our application to work. We have our app running over here. Let me just close this extra window. Yeah, we have our application running over here. The front end is not very fancy because the main purpose of this project was to demonstrate the integration of the model and the front end, and the main purpose was to create an app that a user can use, because most of the machine learning application are not accessible by users. Even if they use it, they don't know it, or at the school level or college level, it is difficult to create a machine learning application that a user can use. We create recommender system, but hardly any user can use recommender system. This is one of the simpler uh, approach of creating the machine learning application that can be used by general public. So let me give you a brief introduction about the front end. So this is the landing page of our project. On the left hand side, you can see a text box. This is going to serve as the input box. Whatever input we wish to calculate, if it is hate speech or not, we put it in this text box. This welcome to hold. This is the output box where we are going to get percentage probability that if a particular statement falls under the category of hate speech or objectionable language. Let's just start with one input. So without focusing much on the input, we will focus on the output. So the model is 99.48% sure that our input falls under the category of hate speech and objectionable language. Now, one of the main reasons why I have mentioned probabilities over here rather than mentioning if it is hate speech or not is that the sensitivity of model. Let's say I want to create a model which is very sensitive. Now it is very sensitive. So what we do, we set the threshold to 30%. Now what is the threshold? If the percentage probability of a sentence is more than that threshold, it will fall under the category of hate speech. If it is less than that threshold, it will not fall under the category of hate speech. If I want to create a sensitive model, I will set the threshold to 30%. That means any sentence whose probability of being a hate speech is 40% will be categorized as hate speech. Although statements with probability of hate speech 40% are not that hateful. They are hateful, but the scale, or if you want to measure how hateful they will certainly be not very hateful. They can clearly not be termed as hate speech in most of the cases, but they are hateful and they are objectionable. If I don't, and on the other side, if I don't want my model to be that sensitive, I want it to be rigid. I don't want it to be that sensitive. Let's say in some cases where everyone every day abuses each other, in that environment, everyone abuses each other. Everyone uses hate speech against each other. In that environment, what we consider as hate speech might not be hate speech. They are going to be hateful if if someone else look at them, but for the people who are residing in that environment, it is not going to be hateful at all. So let's say if the sensitivity or if the threshold is 70%, then for a model whose probability of being a hate speech is 60%, will not be considered as hate speech. So it depends on the threshold that we set. If you want to set it 50%, if you want to keep the model balanced, we can set it 50%. If you want to make our model sensitive, we can keep it 30%. If you want to make our model rigid, we can keep it 70%. That is the main reason why I have displayed the probabilities rather than output if the sentence is hate speech or not. Let's just try with another sentence. Uh, let's say so the probability is 78%. Whatever input we had, the probability is 78%. Now, as I'm saying, please do not pay attention on the inputs. The sole purpose is demonstration, and we are doing demonstration over here. The model predicts that this this particular statement could be 78%. The probability could be 78%. This is about the the model demonstration, or how we take input, how we process it, and how we get the output. Now let's just talk about features of the website. The website is pretty simple, as I have said. We have a tech tab over here. Now this tech tab considers most of the problem that we face, that I have faced particularly, and it suggests some solution regarding it. The first problem, as you can see, I faced was dealing with imbalanced data. There was class imbalance in data, means the total entries which were hate speech were were outnumbered by a great extent by the total entries which were not hate speech. So I'm sorry, I'm actually used to saying we, so I had to actually balance them. I used oversampling for this, long short term memory. This is the network, or this is the network that I have used in creating the model. Why use LSTM? These are standard reasons. BERT as a substitute of LSTM. BERT is clearly the best choice as of now for any natural language processing application. But as I've said, the main motive of this application is to make a machine learning application that could be used by any user, rather than just focusing on backend data and all. So I am working on a project with bot. As soon as it completes, I'll upload test sequence for that project as well. Now, how the model was integrated with web app. There are two methods. The first one is no server approach and the second one is server approach. Let's just first talk about no server approach. So the initial idea or the initial plan was to use no server approach. When I say no server approach, whatever input we are giving to our client side, it would be processed and the calculations would be performed and displayed in the client side as well. There was no need of server. But because of two files or two important concepts which we will discuss in further points, I had to include the server. Now let's see how we can include or how we can integrate uh, our model with our client without a server. So we use TensorFlow.js in this condition. It is the client-side solution that will solve the problem of integration. And there is only one constraint with TensorFlow.js. The constraint is if you have developed your model in Python, you will first have to convert your model in the format that is specified by TensorFlow.js. Then and then only you can integrate your model in the client side. If you don't want to do, or if you cannot do the conversion because of any reason, then you won't be able to integrate your model with the client side without a server. You will have to introduce a server in that case. If you want to integrate your model in the client side, you will have to convert it in the format which is specified by TensorFlow.js. I can show you that format. Just a second. So if you can see this target directory, this target directory has the model, this modeler.json. So this model was initially developed in Python, but then just to integrate it with the client side without the use of server, I had to convert it in the format specified by TensorFlow.js. Although we are not using that approach, we are using server approach. Let's just talk about server approach right now. So server approach, as I have already mentioned, the server is designed in Flask, Python, and the model is designed in TensorFlow. I have also mentioned that because of two major reasons, I had to introduce the server. If I would have found a solution to integrate those two files or those two components in front end itself or in the client side itself, there was no need of server. We will discuss it in the next point, what those two files or what those two constraints were. But right now let us discuss the server approach. So this server is in Python. I'm using the standard API where you take the input from the client side sends it to the server. In server we perform calculations on it, we perform analysis on it, or whatever you call it. We get the output, we send it to the client side back, and the client side displays it. This is the basic this is the basic criteria. If my Wi-Fi is working, just a second. I can show you that diagram. Now, yes. So this is the diagram of integration of the server in the client itself with of the model in the client itself without actually using the server. So as you can see, a trained model in Python, you convert it into TFJS model. This is the format specified by TFJS or TensorFlow.js. You load that model in TensorFlow.js, you load that media, you do processing, and you do the predictions. Now, what were the reason why I had to introduce the server? These two reasons were there: tokenization and sequence padding. Now, this tokenization and sequence padding are necessary. Why? Because our model needs data to be in particular format, and that particular format is achieved by tokenization and sequence padding. What that particular format is, what does the data we feed to model looks like? So it looks like this. If you can see it, I'll show you it in server. It looks like this. This 000 are nothing but padding. Why do we use padding? Because when we are creating model, we are using embedded layers. When we are using embedded layers, we need all the inputs irrespective of their length. We need all the inputs to be of same size, and the size here mentioned is 26. This input is 2D array, or this sequence is 2D array, and you can count the number of entries in this sequence. You are going to find it to be you will find it to be 26. So this is the data that is fed to the model, and we get respective predictions when analysis or when processing is done on this data. And this tokenization and padding, sequence padding, was the main reason why I had to introduce the server. If I would have found any other way which would have helped me in integrating this tokenization and sequence padding files in the client side itself, then there was no need for me to create this server. Easily, I could have made this application work without the help of server. But because I was not able to find any way to include this tokenization and padded sequence file into the client side, I had to create a server. And the server is pretty simple. It does not do much. It is just take input from the client side. It performs pre-processing. It tokenizes the data. It performs sequence padding. The sequence padded and tokenized data is fed into the model. The model gives some output, and the output is sent back to the to the client side. I'm sorry. So that was it. Thank you.